Good morning, good afternoon, or good evening, depending on where you are or when are you watching this recording. Welcome to Skill Me Up Expert Talk. This topic of the day is Azure Key Vault Deep Dive. For the next 45 minutes, we are going to spend our time on learning all about securing Azure Key Vault. A very brief introduction about myself. My name is Karl Ots. You can follow me on Twitter with the tag Karl J. Ots. I'm a cloud and security expert and community leader, organizer, speaker, working on Azure almost a decade now. And I've helped to secure hundreds of applications from these small startups really starting on their first footprints on the cloud or any IT footprint, all the way up to Fortune 500 enterprises. And right now I'm working at Swiss Re, a large Swiss financial sector organization. And there I'm helping to secure their overall cloud footprint. Today we are going to spend our time mostly about discussing the Azure Key Vault key components and how should we use those as a best practice. Really some key considerations based on real projects. The second larger part that we'll cover today is really how do we use Azure Key Vault as part of our overall Azure architecture? How do we integrate Azure Key Vault with services like Azure SQL Database or Azure App Service? What other options there are? This is a really action-packed session. I have lots of materials for you where you can learn more. If you miss some parts, you are free to check the recording in a couple of days at the Skill Me Up website. And with that, let's get started. And yes, I am reminded that please feel free to ask any questions. I will revisit most of the questions if I haven't already talked about them, answered your questions during the session. I will revisit the questions you ask here in the IM chat at the end of this session. And now let's get started. So let's really talk about Azure Key Vault service and really start with the definition, what it is. Azure Key Vault is a service for storing and controlling access and monitoring any application secrets. And a secret is a generic term that really covers any type of connection strings or passwords. And specifically, it can be any sort of string that we can store in the shared or the secured Key Vault. Additionally, Azure Key Vault supports encryption keys, most types all the way up to 3,000, 4,000 bits. It does support certificates as well. There's some integration with existing certificate authorities. There's also a possibility to bring your own keys to the key store as well. Mostly today, when we are talking about Azure Key Vault and how to leverage that across our different services, how to secure that, how to use that in projects, most of the time I'm referring to generally secrets, but it doesn't mean that the same approach won't be applicable for encryption key storage or certificate storage as well. If you double click on the encryption key management, Azure Key Vault is the first party natively supported way for bringing in our own key. A lot of Azure services like Azure Storage, Data Lake, Event Hub, a lot of these services where we store sensitive data, most likely services that are not only on the compute layer, most of those services support bringing in what Microsoft calls customer managed key. By default, encryption at rest is handled by Microsoft managing and rotating the keys, but we are able to bring in our own keys as well, depending on, for example, if we have some regulations that we have to have ownership of the whole process, or in some cases, if we have already established that the key length that Microsoft uses in some of their Microsoft managed keys is maybe not enough for us. Or maybe we need to prove that the keys are actually generated using our own hardware and shipped over from our own premises. The key, pun intended, for Key Vault access control is a selection of access policies. There's a clear distinction that the management pane role-based access control, the role-based access control is meant for management pane access control in Azure Key Vault specifically. But the actual access to the content within the Key Vault is done using editing so-called access policies. And the access policies are a list of access control lists, right? So it's very similar to chmod in our Unix-based file systems. We can define from a list of predefined allowed controls. There's no pre-built-in roles as such. And an access policy always covers the entire Key Vault resource. And what does it mean? It means that as contributor, which is a management pane role-based access control role, as a contributor, I can actually manage access to secret keys and certificates because I have access to manage those access policies. Typically, a contributor is considered as a regular user who is able to create and manage and even delete resources, but they are not considered an access control role, such as a user access admin or an owner. So this is really important to keep in mind when we move forward. A contributor can change access policies. Okay, well, now that we are actually able to assign those access policies and modify those, we need to know that each access policy is actually always assigned to Azure Active Directory identities. There's always this direct relationship between our Key Vault and our Azure AD tenant. On that regard, it's very similar to role-based access control. We can know that there's no external username and passwords. There's no external identity management that's managing access to our Key Vault. Azure AD management is always there. But this also comes at a certain extra cost of operations as well. If it so happens that you move your Azure subscription from one tenant to another, for example, because of migration purposes or because you want to carve out a specific part of your business, or maybe you want to split into different identity zones as you would on your own premises. When you do that, the link between your Azure AD tenant and your Azure Key Vault breaks. So just like you will need to manually re-add all of the role-based access control, you would also need to manually re-add, actually re-link your Azure Key Vault to your tenant, and then manually re-add all of your access policies as well. Okay, another way to manage access to Azure Key Vault beyond the identity is the firewall. Now, there are several network controls available to us. They are branded as a firewall. It's a simple Azure data pane access control list. There are some options that we can choose, but if you're coming from networking background, it's not a firewall in terms of all of the management capabilities there. It's fairly simple. We navigate into our Azure Key Vault resource. We open up a section called Firewall, and there are two different parts. We have something called Firewalls and Virtual Networks that covers access controls access with IP addresses or virtual networks. if we have a specific virtual network available for us in our architecture, that's something that we can open up here. If, for example, most of our developers are coming in from our own premises using site-to-site VPN or express routes, they can be safely allowed to log in using this specific hub type of a virtual network. If we need to add some additional, maybe vendors, maybe some proxies, maybe some other reasons, we can add those here. So these are complementing each other. Another section is the private endpoint connections. It's interesting to note that all of these platform as a service data pane firewalls behave a little bit differently. Storage, SQL, Key Vault, all of these, they have a little bit different approaches. So be mindful when you set these in the UI so that you won't lock your users out. But the main thing to take away here is that by default, anyone from any network location can access it as long as they have an authentication possibility to Azure AD, and they have been added and they have an access policy defined in the Key Vault. And remember, a contributor user in your subscription can perform and make both of those changes. Next step will be to secure your environment to be accessible for certain virtual networks only. Or even further, you could go ahead and configure your private link. That would mean that you could also get protection for data exfiltration. That does come with some added cost of you needing to also configure your DNS names for all of your data services. Okay, there was this small bit here. Sorry about this. So in here we have this allow trusted Microsoft services to bypass this firewall. And this is something that we quite often need to consider. As if you look at the list, you'll see that, for example, Azure Resource Manager, ARM template deployments are actually part of that list. So if you want to access your Key Vault as part of your ARM template deployment, for example, if you want to create a resource that has a connection string or configure some connections within the ARM template, most typically you will fetch those secrets from a Key Vault. Then you actually need to enable this blind trust of firewall trusted Azure services altogether. If you want to use Azure Disk Encryption, a specific extension-based full OS disk encryption service by Azure using dmcrypt for Linux VMs and BitLocker for Windows VMs, then you need to allow this separately as well. And there are some others here as you see available. Azure API management, Databricks, container registry, all of these are fairly often used for access control as well. And one thing that's missing actually here are Azure DevOps hosted pools. So if you are building or if you are deploying your services from Azure DevOps and you're using the Microsoft managed build agents or deployment agents, those IP addresses are not actually as part of these trusted Azure services. So you'll either need to use your own custom agents, you will need to actually manage your own infrastructure to get one specific static IP address, or you will need to do a little bit of, let's say, ugly tricks to allow access essentially for the whole data center IP or Azure region IP address range that are documented, or maybe just consume a little bit more of the deployment time so that as part of your Azure DevOps deployment, you will first fetch at runtime the IP address that you are coming from, then open that up for the duration of your build time or deployment time into the Azure Key Vault, and finally remove that. None of these are perfect options. Essentially, the the only true and trusted here is managing your own agents, which is not optimal and not feasible in a lot of scenarios. Okay, so I've pre-recorded a demo here just to be mindful of the time here. So let's get started and have a look at these Azure Key Vault access policies in a little bit more details. So here's an example of my Azure Key Vault resource. I've deployed it into Western Europe. I have a public DNS name. It's part of my Azure Active Directory. And of course, it's an Azure resource, so it's sitting in a resource group and a subscription. Okay. Key takeaway, it's always tied to my Azure Active Directory. Let's move on to the access control. Now, this is the management pane role-based access control. And you'll see that I have actually 2 access control assignments here. I'm actually the owner of this particular subscription. And even more, I'm actually my Azure AD global admin. So through that, I'm actually also a user access admin for my whole root management group. And that gets inherited into me being the user access admin for the whole subscription, and that gets inherited for the whole Key Vault. But the key takeaway, I'm an owner. I have all the privileges possible to do anything that I want. But nevertheless, if I, as an owner, go in and navigate into my Azure Key Vaults and start checking from the Azure portal that do I actually have what's available here as stored keys or secrets, you'll actually see that I get prompted that I don't have authorization to do this. You are unauthorized to view these contents, and the operation list is not enabled for you. And the takeaway here is that even if I'm an owner, regardless of my management pane access, I cannot see any of the stored secrets in the Key Vault. I need to go ahead and add an access policy, which is separate from all of the standard Azure role-based access control, which is very ironic considering that it's one of those really fundamental security services and it doesn't use role-based access control properly. Okay, to do that, I'll navigate under settings to access policies, and there's this little bit conveniently hidden button called add access policy. You also see those other options that I can enable for the whole Key Vault. Namely, I'd like to point out the Azure Resource Manager template deployment here as well. Okay, I click on the add access policy. I'll get prompted or I'll navigate through this wizard. I can select from a predefined list of access policies. Now, these are not really roles. This is not role-based access control. But if I open this up, the configure from template, essentially it's just a pre-populated list of things that I can do related to keys, secrets, or certificates. Can I renew certs? Can I delete keys? Can I list keys, and so forth? If I select the so-called full template, which is the key, secret, and certificate management, I get pre-populated or pre-selected for all of the permissions available for keys, secrets, and certificates. So once I've selected that, I need to select my Azure AD identity, just like I would for my role-based access control. So I'll go ahead and click select principal. I'll navigate through the wizard. I'll find my Azure AD group, service principal, managed identity, whatever my object in my Azure AD. And remember, these permissions apply to all keys, secrets, and certificates in my Azure Key Vault. These are not specific to a single one. I don't have folders. I cannot set permissions to only a single key. That's something that you'll need to architect around. Now, once I've actually added this access policy, I can navigate to my secrets and see that I no longer see an error message, and there is one secret present in my Key Vault. It's called the root password. And if I'll actually open that up, I'll see two things. Well, first of all, I see my secret unique resource identifier. That's essentially a globally unique, it's a fully qualified domain name. First of all, my key vault is always unique. My key vault always has a globally unique resource name, Karl Key Vault West Europe in this case, and then the vault.azure.net are the Microsoft defaults, just like our storage account. So the first part of my fully qualified domain name is always public, is publicly unique, globally unique, and then the rest is actually just the name of the secret and then the version of the secret and then some unique strings on top of it. That's the URL that I need to fetch using my backend APIs if I would, or using my code or command line if I would do that from another location than manually here in the portal. Okay. The other thing that I can do here is, as an allowed user, I can go ahead and click Show Secret Value. And as you'll see, you can all see my secret password here for my root password. And this is something that then I can copy over and input in the relevant location. So just to recap, I showed you access. I showed you that even as an owner, I don't have access to secrets. I needed to add an access policy. There's all these considerations about least privilege at that point. But when I added my access policies properly, then I was able to get the content there. Each content type is different. So certificates, as I mentioned, they have cert authority integration. Keys have configuration related to the key length and encryption protocols. Passwords or any other type of strings are just stored generically, as I showed you here in the secret content type. So the first, or the definition of the Azure Key Vault was that I was able to securely store secrets and manage access to them, and also audit the access. The key part of this Key Vault is that I can always see who has accessed it. I can always produce audit logs, but those are not actually on by default. So you need to go ahead and enable audit logging. To do that, you'll navigate to your Azure resource. You'll go to diagnostic settings and select audit event type of log category, and then select the destination for your logs. You can send those to Log Analytics, to storage account, if you have access to both of them as the same user who applies that, or if you need to integrate with the third-party CM or just a SOC that's outside of your access, then you can just stream to an Azure Event Hub and use that as your integration to essentially anywhere. It's important to note that, yes, okay, it's a little bit hidden in terms of the name, diagnostic settings, but actually this is not an option that you would add in the configuration of the Key Vault itself if you will do this in Azure CLI or Azure Resource Manager. In Azure Resource Manager, you will just use AZ monitor command, and underneath AZ monitor you have diagnostic settings create, and then you will add as a parameter to that AZ monitor command, you will add the Key Vault resource, not the other way around. So audit logging is something that you'll need to go on and enable yourself. But we also have the usually a little bit more boring, or let's say more vague in terms of responsibilities part, which is actually scraping those logs and actually making some insight from that. So Azure has something called Advanced Threat Protection category of alerts, which are essentially quote unquote AI alerts based on those audit logs. Microsoft has predefined some of these threats that they will raise an alert to you if you just enable this. And you'll see we have very interesting things here. We get an alert when there's an unusual user who's accessing it. Typically, they don't do anything with it, but now they suddenly access. We have an unusual query pattern. Now suddenly they want to access and download everything. We have access from a Tor exit node, and all of these suspicious things that usually will be behind our security operations team to actually worry about. This is something that we'll just get out of the box by enabling this. Essentially, they come at the cost of the Azure Security Center. Here's just one example of that. You'll see an unusual operation pattern in our Key Vault. This got raised. You'll see that the operations are really about authenticating in, unwrapping keys, getting the information. And as you'll see, we have quite an interesting reason here. It tells me that the application or this identity does not usually come from this IP, and this vault does not even have this operation usually, this unwrapped key. So this is something that we'll need to have a look at and see if this is legitimate or not. Quite insightful, quite actionable, and also something that we don't get prompted for this so very often. Really recommend you to turn this on. Another thing to consider from your from your event or alert point of view is to set up automation using Azure Event Grid. Azure Event Grid is a fully managed service where you subscribe to any events that are happening in your Azure infrastructure or any custom solution if you want to push to those events. But essentially, I just need to configure in my Azure Event Grid a subscription. I just subscribe in my Azure Key Vault resource to any of these events. So if you ever had the case that the application's certificates are getting renewed at the time when everybody is on vacation, or nobody knows what's the expiry date, so we can't even plan for that. All of these are things that we can actually natively get as an Azure Event Grid event. We can subscribe to those events. We can fire any logic based on that. We can start off an Azure Logic app. We can start off some remediation steps automatically. We can build our own key renewal automation here, or we can just push this message to a webhook or Azure Microsoft Teams or whatever we prefer to do. And that's our segue into integration between Azure Key Vault and other Azure services. I mentioned earlier these different types of data protection services. So Azure Key Vault can be used to encrypt data at rest on those data services. It can also be used to encrypt data in transit for services like Azure App Service. And also it can be used to store connection string securely in Azure App Service, such as to an Azure SQL. Another key topic that I'd like to talk to you about at this point is the Azure Active Directory Managed Identity, or Managed Identity for Azure Resources, as it is called now. Managed identities are a way of providing Azure services an Azure AD object automatically. It appears as something that it appears the same as our user or a group or service principal that we will create manually, but this is something that's tied to the lifecycle of our application resource. So we can use this identity, essentially the app itself, to authenticate to any service that supports Azure AD authentication, such as Azure Key Vault. Well, it's not limited to there. And that means that we can actually get rid of any type of credentials in our code. Instead of configuring connection strings into our Azure applications, Azure App Service for getting access to an Azure Key Vault, we can just tell Azure, hey, this is our application service, grant it this particular access policy within our Azure Key Vault. That's it. That's all we need to do. There's no credentials to leak because there are no credentials. Microsoft makes sure that the Key Vault is only accessed by identities within our Azure AD. We make sure that we grant only this particular identity to access these credentials or these secrets. And then Azure again makes sure that it creates that identity when we need it for our Azure App Service. Let's have a look at that in more detail. So here is again an example of my root password, just a secret stored in my Azure Key Vault. To configure this to be used in my Azure App Service, I'll just copy this resource identifier that I talked about earlier, this unique string. And then I can go ahead and configure the utilization of this in my app service. So I'll navigate to my Azure App Service instance. I'll navigate to settings and configuration. And underneath here, I'll have application settings where I can configure connection strings that are stored essentially in this sandbox environment's web config. That's fine and dandy. So when I open up this wizard to store this new connection string here, you'll see that as my MySQL password here, I'm of course sharing passwords because of course my root password is the same as my MySQL password for this demo. So the name of my parameter or variable or connection string in this case is MySQL, and I need to use this reference. So I'll use this at Microsoft.keyvault, and then I pass in the secret URI of my root password there. And that's it. That's the only thing that I need to do. Now, Microsoft, now this app service knows to populate this particular value at runtime in real time. So if I need to change this root password, because now you all know what my password is, I can go ahead and just make that change in my Azure Key Vault, and that gets automatically propagated here in my app service. That's now nice, but we haven't yet configured that identity. Now there's just someone who wants to access my Key Vault, but we haven't granted that Key Vault, that someone any access, any identity. It doesn't authenticate yet. So to do that in our Azure App Service, we'll navigate 3 steps below from configuration now to identity, and go ahead and select the system assigned managed identity so that we are always on the same lifecycle. We could use user assigned if you want to manually configure it, just like a service principal. And the only thing we need to do is just click the status from off to on and then save, and boom. Now you'll see that this resource is registered with Azure Active Directory. You can control its access to ARM, Key Vault, etc. We have an object ID. This is just like our regular user or service principal or a group in our Azure AD. It has an identity now. Even though it's a service, it's our platform as a service managed web application. It's essentially a server that just happens to have an identity. Microsoft makes sure that authentication certificates that it uses to authenticate are refreshed as often as needed. We don't need to worry about how it actually authenticates. We just know that this is the ID. We can trust that the authentication is done properly. So now that we have created it there, we can go back to the Azure Key Vault and navigate to the access policies and search from that same select principal view. Now, instead of a user, as I had earlier, I can just search for the application name. Very easy, very straightforward for a developer. This is my server name. I want to grant my server that access. It's the same name. And that's it. Now I have my user that has very specific kind of owner privileges, that has all privileges to keys, secrets, and certificates. It's secured using my own MFA and other conditional access. And then I have my application that I have specifically granted only those secret list and secret get permissions according to the least privilege principle. So I need to hit save and I'm done. Voila, access for both my user and identity secured in my application. Okay, another integration point here. Let's talk about securing, or let's talk about using bring your own key for encrypting data at rest using Microsoft SQL as Azure SQL as a service. To do that, by default, if I navigate into my Azure SQL logical server, so-called SQL server, which is not the Microsoft SQL server that you would install on your virtual machine, it's just so named. By default, we are using the service managed key or Microsoft managed key. As I mentioned earlier, this is something that Microsoft does for us. Everything is encrypted at rest. It's encrypted using 256-bit keys, and Microsoft at this time, Microsoft actually rotates the keys every 90 days. If that's not enough, or if we need to for some other reason, we need to be the one who control this, we need to select customer managed key. We are the customer, of course. To do that, we have native integration with Azure Key Vault. So if I have access to the Key Vault myself, I can just click the select vault and then the select key. As you'll see, we'll have the key picker here. I can select the encryption key there. If I wouldn't have this, or if I would want to build this in an infrastructure as code or in an automated environment, I will need to provide this unique resource identifier, just like I would for the app service. So this is just a little bit prettier than the app service integration. So as you'll see, instead of the select key in here, I can actually just enter the unique identifier at this point. Sorry about this. And as you'll see here, yes, there you go. If needed, we will try granting these permissions on your behalf. So what it does is that it creates again that managed identity and tries to add that in the access policy of your Key Vault. If that doesn't happen automatically, if you don't have access to do that, then you can again do the same things, same tricks as we did for Azure App Service. Create that identity, add that to an access policy, and then reinstate this. Perfect. So an overview of this secret management altogether. And if you have a look at this very basic 3-tier application, we have a front end in easily scalable, nice Azure Platform as a Service, Azure Web App. We have some binary static content in Azure Storage, and we have some backend machines in Azure Virtual Machines. And then we have maybe some APIs that we call that are built by some third parties. Maybe we have some subscription keys that we have paid for or something like that. Well, there's tons of secrets here that we can consider. Let's go through a list of all of them. So of course we have a virtual machine admin password. If you don't have Azure AD integration there or Azure integration, you need to store that password somewhere, preferably centrally and with an audit log of who has accessed it. Then the application itself or the front-end application needs to connect to Azure Storage. So there's either the storage API key or some other way of connecting to it. There's that API key that I mentioned as well. Yeah, then we only need the certificate. And if you want to use bring your own key for Azure Storage and Azure Virtual Machines, we can use those keys as well. And all of these we can put inside an Azure Key Vault. Now, Some of these we can actually even go a little bit further. This is a Key Vault view. So of course we want to enforce Key Vault at all places. But for example, Azure Storage supports a similar type of managed identity as the access policies of Key Vault. So we can actually scratch this storage API key number 2 here, and instead of that, grant managed identities for both Azure Web App and Azure Virtual Machine, and configure those as data pane role-based access control assignments in Azure Storage. That's even better than the access policies that we are using manually, because a contributor can make them in Azure Key Vault. And just as a sneak peek before we move to the next slide, even Azure Key Vault is getting better in this. There are in private preview already some hints at proper role-based access control using Azure Data Pane role-based access control, so that we have a vision where we will get those access policies out of our minds, but it's still a long way before they come into other tiers of public preview and then finally generally available, if ever. Sometimes all of our features don't get to see the daylight. Okay, so quick takeaways from this set. You should really lock down the access to your subscription and really talk about the scoping of your role-based access control, because even if you have done your due diligence and removed owner and user access admin from your subscriptions, you should know that quite often the contributor is considered as someone who does not have access to manage access of others. And in Key Vault's case, that is not the case. So you should be wary of where do you grant your developers contributor access and where do you place your Azure Key Vaults. And on that note, you should really use one vault per application environment. You shouldn't share, even within the same users, within the same development team, you shouldn't share a Key Vault across development and production, right? You shouldn't use the same Key Vault that you use for application-specific secrets across applications. You can have some shared Key Vaults for whatever it is you want to share, but application-specific secrets should always be stored in separate Key Vaults and separate environments as well. It doesn't cost anything. There's no fixed cost or additional Azure cost for creating a new Key Vault. You always pay for the utilization. How many calls do you make? There's some operational overhead. Sometimes you need to start automating, getting those events with event grid, enforcing some parts using Azure policies and so forth. You should always create your Azure access policies for each of those vaults, and you should definitely turn on the firewall, even if it is quite broad, because again, by default, anyone who's a contributor can invite anyone to your Azure AD, and that means that anyone with an email access can then just get access to your Key Vault. So limit that, add an extra layer. And there are some other ticks in the box that you can add. There's purge protection and soft delete. That are very nice features to help you sleep a little bit sounder. And you should definitely enable those at your infrastructure as code, but also at your enforcement of your policies as well. All right. With that, I'm opening the floor for questions. Just very briefly, we covered the core concepts of the Azure Key Vault service. We covered some best practices, and we covered how to integrate with Azure App Service and specifically Azure SQL. If you have any questions, please feel free to ask those here in the chat. Otherwise, I look forward to seeing you in our next 2 expert talks that I'll be hosting. The 20th of August, I'll be talking about Azure security best practices. And the 2nd of September, I'll be talking about top 10 Azure security fails and how to avoid them. A very subjective view, of course, but a fun session nevertheless. All right, thanks for listening. Again, my name is Karl Ots. My Twitter is @KarlJOts, and see you next time.